And basically, the meaning of the word integration, you must be knowing that it is the summation. What is the meaning of integration? The first word, what we have heard about integration, it was nothing else but the place which we connect with the national integration. And the meaning of the word integration is nothing else but summation. That means to put small parts all together. Okay. So actual meaning of this integral will be clear to you when we start studying definite integral, not the indefinite integral. Okay. So gradually, I will be explaining you what is the meaning of term integration also. And since the integration has got the meaning summation, okay, and first letter of the word summation starts from letter S. Okay, so sign for integration also is like that. Okay, so this is elongated one, means it has been given some more height so that it appears different than the English letter S. Okay, but basic meaning of this sign of integration is summation, and the symbol has been derived with the help of that. Okay. Now, again, one more meaning I would like you all to understand that this is an anti-derivative procedure. Means what is integral? What is integration? So, integration basically is anti-derivative procedure. Anti-derivative procedure or anti-derivative process. It will so happen today, students, that because of size of the board right now, I will have to clean the board so many number of times. So tomorrow onward, this problem you will not be facing. That's my gentleman promise. Okay. So next class, whenever we do have, we will not be having the class on the small board. We will be having the class on the big board. Okay. So here right now, integration, if I considered as anti-derivative procedure. So what is the meaning of the word anti? So your common observation, okay, of this particular word is mostly used for antivirus. Okay, you are aware about the computer and the technology which is being used in the computers. Okay, so when we try to develop any program and then there is some virus, suppose our computer is affected or infected with some virus. So what does the virus do? So virus basically, okay, it it stops the proper working of that particular program. Okay, and because of that, again the virus also is a very specific kind of program which does not allow the other program to run properly. Okay, so this is the basic meaning of the word virus. And anti that means which will be working against the virus. Okay, so just like that, whatever is the meaning of the word derivative, anti-derivative, that means such an operation which works opposite to that of differentiation. Okay, I will just ask you to recall the formula. What is d by dx of sin x? Can you please tell me the formula derivative of sin x?
Cos X.
Cos x, perfectly all right. Okay, means what exactly happens that this derivative is one such procedure. The nature of sin x, it gets reduced or it gets converted into cos x. That means, for example, suppose if there is one operation like square root, and within the square root sign, suppose if I write 121. So what exactly is this operation? So output of this operation will be such a number, okay, which when multiplied by itself, it gives you the product 121. Okay, so in the same manner, here derivative of a function is also a kind of mathematical operation. And you might have understood that derivative by using the first principle, we normally write f dash x, the derivative in the form of limit h tending to 0, f of x plus h minus f of x divided by h. The first principle you are aware about derivative. So how derivative works on sin x and how are we getting the answer is equal to cos x. Details of all these things, they are hidden in the definition of derivative. That means first principle of derivative. Okay. So right now, this is not the point for me to discuss how derivative of sin x is equal to cos x. But I would like to use this particular example just to explain what is the meaning of integration. Though basically indefinite integral has been taught to you all in your classes, but for my satisfaction also, I would like to introduce indefinite integral from my side. Okay. So when we try to use this word NT, that means the effect of derivative, this will be removed. Okay, the effect of derivative will be removed. So first of all, we see that when we perform the differentiation, what is the recentmost output with us? Cos x. Okay, means cos x is the recentmost output. Means we have obtained this function cos x after operating derivative over sin x. Okay, so when we wanted to remove this particular effect, what we are required to do? We are required to go for operating this. Means on this function cos x, we try to operate anti-derivative. Anti-derivative. So anti-derivative of cos x, what should it be? It will be sin x. Okay, because derivative of sin x is equal to cos x. So on both the sides, suppose if you are trying to write down anti-derivative of left hand side, so it will be equal to anti-derivative of right hand side. That is same operation, then equation remains unchanged. Okay, so that thing happens. So here, if I perform anti-derivative operation on both the sides, so this anti-derivative and derivative, these two will nullify each other. This anti-derivative is that particular operation which nullifies the effect of differentiation. Okay, so these two operations, they are cancelling each other. As a result, only sin x is left over here. So we write anti-derivative of cos x is equal to sin x. And this anti-derivative only has been given the symbol like integration. And one more thing which I would like to clarify. Here we are having a function of variable x, sin x. So we differentiated this function with respect to variable x. Okay. So whenever we are required to go for antiderivative, that antiderivative or integral that also has to be performed with respect to the same variable. Okay. So this symbol of elongated x, it should always be followed with respect to that variable. Okay. Are you understanding that? Since we differentiated the function with respect to variable x, so to remove the effect of this derivative, anti-derivative procedure also has to be performed with respect to x. And this is the reason that along with this particular symbol, we are putting this particular sign dx also. Means it completely shows that we are integrating with respect to x. So this is the particular symbol. Okay. And which function are we integrating? So we are integrating cos x. So as I said that integration, that means anti-derivative procedure. So this anti-derivative procedure of cos x, this will be resulting in the function sin. And we write the constant of integration. Okay. You know why are we adding the constant of integration? So right now, just to start with that integration is nothing else but an anti-derivative procedure.
Sir, I had a doubt.
Pardon?
Sir, I have a doubt.
Yes, what is the doubt?
Sir, like you told that integration is nothing else than summation. So why can't we write it
Yes.
summation I equals to dx up to n?
Yes, this symbol, na? This symbol I is equal to 1 to n. What usual symbol we are utilizing? Are you talking about this one only, na?
Yes, sir.
Yes. So basically, we can apply this symbol for integration also, but that can be applied only in the case of definite integral. You see what is happening? The moment you write this symbol, I is equal to 1. Suppose within the bracket, if I write the quantity like xi, suppose this is the particular way in which we are trying to write down summation of some quantity. Am I right? So what happens basically, there is one minimum value of this symbol I, and there is one maximum value also. Am I right? So whatever large may be the value n, whatever large number it is, but ultimately it has to be a finite quantity. Okay. So this symbol is applicable only in case of finite quantities. Okay. And here what we are doing, that is indefinite integral, means we are not trying to fix the value of this variable. So this symbol we are not required to write, we are not required to use right now. Okay, when we shift to definite integral, I definitely will be showing that definite integral will be giving you a finite numerical value, and that finite numerical value can be written as a summation, and this particular symbol definitely can be utilized over there. Just for your information, children, this symbol we are writing as definite integral as a limit of sum. Definite integral as a limit of sum. Right now, for this particular year only, this article has been deleted from CBSE. Okay, but I definitely will be showing you that thing, since I told that integration, that means summation. So I definitely will justify whatever statement I made in front of you. So just for your knowledge purpose, I will be showing you that definite integral definitely is expressed as a limit of sum. So this symbol will be utilized for definite integral. Correct? So I hope Atharv, your doubt is clear.
Yes, sir.
Okay. But how it happens? Okay, I am keeping this particular thing pending. I will be discussing that thing when we start actually understanding the concept of definite integral. Correct?
Yes, sir.
Okay, thank you. If you are having any other doubt, you can ask that to me. First thing, which what I try to clarify from my side, why are we using this symbol only? Why are we using this particular letter S? So I justify S stands for summation. So this letter has been considered as a symbol for integration. Then I shown you what is the meaning of this particular quantity dx. So this always reminds us that whatever function we are writing within the integration, whatever function we are writing over here, this function needs to be integrated with respect to this variable. Correct? Okay. So that's why these two quantities shall always be written together. The symbol for integration and the variable with respect to whom the integration is being done. These two quantities shall come together. And we shall be writing any specific function within this. Suppose if I write log x within this. So I will be calling it, this is integration of log x with respect to x. Okay, how to calculate this, how to find out the value of integration, that is something else. We are gradually learning that. Okay. I would like to justify this particular thing also. Why are we adding the concept of integration? Why it is essential? Okay, so let me ask one question. Suppose if I write fx is equal to sine x plus 2, I write some other function like g of x is equal to sine x plus 3. I write some more function hx is equal to sine x minus 100. What about these three functions? Are they all equal? So all participants, those who are attending the class, I request you to please unmute yourself and try to answer this particular question, whatever I'm asking to you, so that your actual participation I will be able to understand. Okay, because right now what is happening? You all are on the other side of camera and I am this side of the camera. Okay, so I will not be able to see how many students are actually connected to me right now. Okay, so that I will be able to understand only when you respond to my questions. So my question is, if I define f of x, g of x and h of x in this specific manner, And if I ask the question to you whether all these functions they are equal or they are not,
Unequal,
so
sir.
what is your answer? Pardon?
Unequal.
Unequal. What is the reason that they are unequal?
Sir, their intercepts.
Intersect means
The constants added.
yes. Okay. These three quantities which are being added along with the variable part. Okay. These three are different. That's why all these functions they are different. But now, if I try to find out derivative of f of x, where f of x is sin x plus 2. So what answer are you writing for derivative of f of x? What is the answer?
Cos x.
Yes, because this sin x, when you are differentiating sin x, the derivative of sin x will be giving you cos x, and derivative of this constant will be equal to 0. Okay. Suppose if you differentiate this g of x, so what is the derivative of g of x right now?
Cos x.
Cos x. Yes, perfectly aligned. And suppose if we differentiate the third function also, in that case, what will happen to that?
Cos x.
Cos x, correct? So now you see that f of x, g of x, and h of x, all three were different functions, correct? But all of them did have the same derivative, correct? So now suppose now I try to go for antiderivative of cos x. Okay. So what was the actual meaning of antiderivative or integral? It is that procedure which removes the effect of differentiation. Okay. So now you see that when you try to this was actually the differentiation which is operated on this function so as to get cos x. So antiderivative means antiderivative will be like that cos x dx. If we go for operating antiderivative means removing the effect of this differentiation. So we will be getting the answer is equal to f of x. Okay. Likewise, suppose if I consider this equation, and again, if I try to integrate cos x according to this equation, what answer will this give me? What answer this equation will give me if I operate antiderivative procedure for cos x? It will answer in g of x, correct? And suppose the third equation which I consider integration of cos x, then as per the third equation, what answer am I going to get? I am going to get h of x is the answer. Correct? Now see what is happening. This fx, gx, and h of x, these three functions, they are all different from each other. Okay? So what does it mean that when we try to integrate cos x with respect to x, if we get three different results, f of x, g of x, and h of x, so does it mean that one function, if it is integrated with respect to x, can it give us different answers? So students, you have come across all such situations in mathematics. If we are given one question, then that one question has got exactly one answer associated to that question. We never have come across that situation that one question is having more than one correct answers. Okay, but surprisingly, this indefinite integral, it is one branch of mathematics where one question can have more than one correct answers also. Correct? So here as we have seen that, okay, all these equations what I have written, derivative of f of x is equal to cos x, these equations, they are all correct equations, okay? Means three different functions, when we differentiated them, they all gave you the same answer cos x. Correct? So now if we integrate cos x, integration of cos x will remove the effect of derivative. So after we remove this derivative, in the first equation we are left with f of x as the answer. In the second equation, if we remove d by dx, then we are left with g of x as the answer. And in the third equation, if we remove derivative, we are left with h of x. So does it mean that if one function is integrated, it is going to give us three correct answer, f of x, g of x, and h of x? So my answer is yes. Okay, because all three equations what we have differentiated, we have followed the correct differentiation, and we all got After differentiating f of x also we got the answer cos x. Differentiating g of x we got the answer cos x. And differentiating h of x also we got the answer cos x. Correct? So when antiderivative or integration has been performed on cos x, it can give you the result f of x, it can give you the result g of x, and it can give you the result h of x also. Okay? And now we see what happens. In order to think what is similarity between f of x, g of x, and h of x, and what are differences between these three or among these three functions. So we see that similarity is each one of them have got the part containing variable. All of them have got the same part containing variable. Sin x is the common part which is containing the variable x. And this fx or gx or h of x, they are all different from each other only because of different constant quantity. Okay. So what is difference between fx, gh and hs? This is the numerical value of the constant involved. Okay. So suppose we do not write the numerical value of cos x. Sorry. Suppose we do not write the numerical value of constant. In that case, what will happen? We will be able to write down symbolically a term like c, which we are considering as a constant quantity, which is not the variable. Okay. So when we try to symbolically represent the constant quantity, not by numerical value, but by the symbol. So in that case, now you try to think over. I am writing sin x means f of x is equal to sin x plus constant. I am writing g of x is equal to sin x plus constant. And I am writing h of x also equal to sin x plus constant. The moment I start representing these numerical values in terms of a symbol like c, then there is no difference between f of x, g of x, and h of x. All of them will be equal now. So I hope you have understood that when we perform the antiderivative operation on any function, it removes the effect of differentiation. That's first thing. Second thing, we are required to add the constant of integration also, because this is the generalized form, because in the generalized form we write the quantity containing variable also and quantity containing constant also. Okay, so that's why the constant of integration also needs to be added with each and every solution of question based on indefinite integral. Okay. Then there are different methods of integration. So far as methods of integration are concerned, I would like to write integration by substitution. That's the first method. Second method, we will be using integration by breaking into partial fractions. And third method, what we are going to utilize, that is integration by parts. Okay. So these are different methods which are adopted for integration. Okay, which are adopted for integration. Correct. So we shall be learning details of one by one different methods. Okay, so just wanted to know from you all, do you all know the formula for integration, or should I provide the formula for integration to you? Please answer my question.
I know, sir.
You know the formula for integration?
I know, sir.
Yes, sir.
Okay,
I
Atharv
also know.
knows. Okay, Kumud also knows. What about Sayed? Sayed, are you
Sir,
on the
I
line?
think he left.
Okay, he has left. Okay, no problem. Okay, in that case, both of you children, you are already having the formula in your mind. So I will request one small thing. When we are solving the questions in this class, so at least the list of all formula of integration you should keep with you. Okay, and the moment you keep the list of formula with you, you will be saving your time. Okay, so next class whenever I take, okay, you should be having the list of the formula with you. Okay, so should we start with integration by substitution?
Yes, sir.
Okay. So one more thing I would like to ask before we start with integration by substitution. Tell me one thing: any specific doubt or difficulties you are having on integration? Any particular question which you have solved, try to solve in the class, and you're not able to get the answer of the problem?
No, sir.
No. Okay. Then we write integration by substitution. And in that case, students, before we start utilizing this particular process, let me ask you one question. Okay, let me write d by dx of sine 2x. What is the correct answer for this? What is the derivative of sine 2x?
2 sine 2x.
Yes. 2 into cos 2x. Okay, when you differentiate sine 2x, derivative of sine function will be cos function, so you get cos 2x, and you are writing the derivative of 2x also in the form of 2. Okay, so when you try to integrate 2 into cos 2x with respect to x, what answer are you going to get? Say differentiation of this function is equal to right hand side. So to remove this differentiation, what are you supposed to do with RHS? Antiderivative. Okay, to remove this derivative means what will we do? We will go for antiderivative, that is integration. So basically when we try to integrate this right hand side, so integration of 2 into cos 2x dx, it should give you the quantity like sine 2x. Okay, so here we write the answer in the form of sine 2x dx. Okay, so here suppose this is a constant quantity, and you are aware that in integration and in differentiation, the constant term, okay, we always try to take it out, because the process of differentiation or the process of integration multiplied the constant which is multiplied to the function, that constant does not get altered, or it doesn't get changed after integration and differentiation. So basically this constant will be out of integration, and we try to write down integration of cos 2x is equal to sine 2x. I committed one mistake also. I should have not written dx here on the right side like that. Okay, so if we try to write down the quantity like integration of cos 2x dx is equal to this 2 which I was writing on the left hand side, it will now be written in the form of 1 by 2 times sine 2x, and finally we are required to add the constant of integration. Correct? So now you try to compare this situation. You try to compare this situation with standard formula. The standard formula is integration of cos x dx is equal to sine x plus c. This is the standard formula. Okay. And now you see what is happening. Here x, that means the variable. The variable was having the coefficient 1. I am pronunciating especially cos of 1x. Cos of 1x. Cos of 1x is equal to integration of cos 1x is equal to sine 1x plus c. Okay. And here integration of cos 2x is equal to 1 by 2 times sine 2x. So if I want to find out the value of cos 3x dx, what answer should I write?
1 by 3
1
sine
by
3x.
Yes, I should write the quantity like 1 by 3 times sine 3x plus c. Correct? So this is the way in which we are required actually to go for using. I have not shown you the integration by substitution right now, okay? But I just tried to show you that when we are integrating the standard functions using the standard functions, we do not face any difficulty, okay? Because formulae for differentiation and formulae for integration are also known to us. But now suppose if I try to find out the integration of this type of function, this is function of a function. You can understand very well. On the variable x, from variable x, suppose this is variable x, and I wanted to get the output is equal to cos 2x. So first of all, on this variable x, I will have to multiply this by 2 to get the quantity like 2x, okay? And on this input, okay, I will be operating the cosine function so that I am getting the final answer is equal to cos 2x. That means on this variable x, how many different operations are performed? First operation multiplication by 2 and second operation the cosine function. Okay. So this is called the function of a function. Okay, this is called the function of a function. So problem is that when we are integrating only a function of x, we are having the standard formula. But we are integrating the function of a function, then we cannot use the same standard formula. Okay. So here you see that suppose if I write e to the power x square dx, suppose if I write the integration of e to the power x square dx. So I don't have the standard formula because this is e to the power x square. X square itself, it is a function of x, and when I write e to the power x square, it becomes the function of function. Okay, so when we are integrating a function, the situation is something different, and if we are integrating a function of function, situation will be little bit different. Okay, so why are we using integration by substitution? The first situation, first answer is that integration by substitution is to be used for integration of function. Okay, the first situation what we are discussing right now, integration by substitution means why why do we use why do we use substitution? Okay, this is first question which should come to your mind. What is the purpose of using the substitution? Okay, children, purpose of using the substitution is to convert given function of function into a standard function. Okay, what is the meaning of this standard function? Means variable operated by only one operation. Okay, this situation I personally call as standard function. Okay, means say integration of this type of function, it is not possible for us to find out directly. Okay, so we shall be converting this situation in the form of the standard function. Okay, so we are required to make use of substitution. Okay, so first of all, three out of three questions. Why is substitution needed. Means when we are following this one, so first genuine question comes to our mind, why do we use the substitution? So answer is very simple. Answer is substitution is required to convert given function in the form of such a function which is having only one operation involved. Okay. I'm sorry. So we are required to go for using substitution so that the given function is converted in the form of the standard function. This is the basic purpose of using the substitution. Second question would be, what is substitution? What is the substitution used for a question? So answer to this question, what should be substitution? It depends upon question to question. Okay, means there is no standard substitution which shall be working always in all conditions. Correct? And how substitution works? How substitution works? So these three questions right now should be there in your mind. Why are we using the substitution? That's first thing. What should be the substitution? That is second thing. And how does the substitution work? Okay. So these three questions right now I am keeping pending for you people. Okay. Tomorrow onwards, or tomorrow means next Saturday onwards, we shall be working it in other details. Okay. So today I would like to give a break at this moment right now because of one simple reason, children. I'm very sorry, but I have to travel long from Bhopal back to Indore. So right now I'm not in the position to continue this lecture for the entire duration of time. So next Saturday, definitely when we are meeting, I shall be compensating this time loss also, and that will be clarifying the concept of why, what, and how. Okay. So for today, if you could excuse me, I'm leaving this class right now. Okay. And tomorrow onwards, Saturday onwards, we shall be continuing with the topic. And meanwhile, okay, I will be sharing my telephone number also because today I have joined with some other number. My mobile number also I am writing for you, 94253 46505. So if you are having any doubt or any difficulty, you can share that doubt or difficulty for mathematics on this particular number. Okay. So for today's lecture, I am taking a break. Okay. And students, feel free to give your feedback also. Correct. So thank you very much, students, for today.
बिल्कुल मुकुल भाई, thank you.
Anil sir, thank you very much.
Thank you very much.
Actually, means today I could not continue because I had to travel from Bhopal back to Indore.
Yeah.
That
Yes,
was
we
the
know.
problem.
नहीं, we know it.
Sir.
फिर भी आपने join किया, बड़ी बात है.
नहीं, I was determined to join the class.
Yeah.
Only one small problem was that I could not complete the class right now. But that
No
will
issue.
be definitely compensated in the next meeting.
Right. Please.
Okay.
Thank you. Good night.
Thank you, Anil bhai.
Good night, students. Good night,
Thank you,
students.
children. Okay. Thanks a lot. Thanks a lot.